This is a conversation with Youssef Benmokhtar. Youssef is the CEO of GelSight, a Boston-based company that makes high-resolution touch sensors. In this conversation, we talk about how GelSight's touch sensors work, their new collaboration with Meta AI, formerly Facebook AI, to make a new low-cost sensor called Digit, the digitization of touch sensing and robotics, how GelSight is investing in community and open source software, and we talk about Youssef's professional path in several industries. This is the SenseLink Acts podcast. Thank you to our founding sponsor, Open Robotics. And now, here is my conversation with Youssef Benmokhtar. Hi, Youssef. Would you introduce yourself?
Absolutely. Youssef Benmokhtar, CEO of GelSight, and a high-tech executive for the last 25 years, and excited about this interview and sharing my thoughts with the audience.
Mm-hmm. Tell me about GelSight.
So GelSight is a MIT spinoff. We have a very unique technology. We have an imaging-based digital tactile sensing technology, which basically allows us and our customers to get a 3D information of anything our sensor is in contact with, regardless of the material properties that it's in contact with. That's the essence and the core of our technology.
Yeah, and so you have several products that all kind of work this way. Can you tell me at a high level how they work? Like, how are you understanding the deformation of the material and inferring touch information?
Absolutely. So we have a unique proprietary elastomeric material.
What does that mean?
So it basically means it's a material that has kind of elastic properties where it can conform easily to surfaces that it's in contact with, but still keeps some rigidity to it and has optical properties to allow basically to be integrated into an imaging system.
So I'm picturing like a transparent silicon. Is that something
It's
like
very
it?
similar to that. Absolutely, you're right. It's something very. It's basically a polymer-like material that lets light go through it. So the essence of our technology is we have this material. We coat it with a reflective surface, and we basically illuminate it with RGB light, and place a camera behind it. And now we have the ability to take scans with these cameras using a technique called photometric 3D reconstruction. And that's basically the essence of GelSight technology.
Okay, so let's see, I've looked at some of the images and they're quite cool from this technology. So it looks like you'll have the gel, and it looks like you have the light shining from different sides of the gel so that it gives you different shadows when the gel is pushed into by an object. Is that correct? Or how does that work? Like, how do you set up the lights, basically?
Yes, but I think the lights is really more about getting the most uniform light possible
Okay.
at different wavelengths. So we use red, green, and blue, and making sure that the surface is uniformly illuminated with each one of these different LEDs. And then we have a proprietary algorithm that's using the images captured at each one of these wavelengths to reconstruct 3D from that.
What's the significance of the different wavelengths? Why are they necessary?
Well, that's the principle of photometric 3D.
Would you tell me a bit about it? I guess I don't know very much.
So that's something that I'm not an expert of. I think that's something our co-founder could better explain, since he's the kind of the inventor and the one who developed the algorithms. But it's basically, having 3 images done at different wavelengths, and knowing what those wavelengths are, basically being able to get those 3 different images, he's able to build an algorithm that builds 3D information from that.
So I'm wondering, like, maybe this is wrong, but this is how I'm thinking of it. Perhaps having different colors lets you separate them in the image space, so you can get more dimensions, you get different views a spec. You get different views from each of the lights because each of them casts a shadow. And so if you have, say you do red, green, and blue lights, now you can separate it into red, green, and blue in your image, and you can kind of tease those apart, and that might be more useful for analysis and inferring 3D structure. Does that make, is it
Yeah,
kind of
I
like
think
that, or?
yes, it's kind of like that. Yeah, absolutely right.
Cool. And you mentioned that the sensor is reflective. Is that just on the side that's touching some
Correct.
object, or?
Yes, that's correct.
Okay.
Yes, because basically you need that reflection is what allows you to build that 3D scan. Basically,
Is it reflective or just opaque for this kind
it
of
is
thing?
actually it is reflective.
Why do you want it reflective?
Because you want to basically keep the light within the system, and again in a very uniform way. So any kind of light dissipation outside will make
Hmm.
the computation of the 3D very difficult. So
Oh,
you
okay.
want to have actually, I think opaque is actually another way to look at it, but you need to think about it as it's very opaque, like light is really not going through.
Oh, so you mean you're keeping all of the light within the system? It probably
Correct.
helps. You don't have to normalize it or something because you know how much light is in it, and thus you can have very accurate calibration when it
Correct.
deforms.
Correct. You avoid having to denoise and other things like that.
Huh. Okay. So what I'm imagining now, we have the lights behind a piece of gel. The gel at the front of it, in the part that will touch things, has some
Yes.
sort of reflective or opaque, like thing that doesn't let light through. And you push into the top of the gel, the part with the reflective part, and it deforms it so that, and then the gel deforms, and you see kind of like shadows or something within the gel that you use to infer how the 3D, how the gel is being deformed in 3D.
Correct. Yep. You got it.
Now, let's see. So, how long has this method been around?
So the company was, founded in 2011. I believe the first papers describing the concept were a few years before that.
Yeah.
So I want to say maybe 2009 is the first time that this kind of idea was described.
Hmm.
And then our co-founders, Ted Illison, who is a professor at MIT, and his student, Kimo Johnson, wrote those papers and got actually a lot of interest, not only from academia, but also from industry. And that gave them an idea to say, well, why don't we just, found this company
Cool.
and try to do something with that. Just respond to the, what they felt was a strong demand signal.
Hmm. Why? I'm just wondering what makes like I'm sure that like so I have a little bit of experience in computer vision. And so thinking about like, okay, we want robots to touch things. Now using some sort of gel and looking at how it deforms, to me, it seems like like kind of a solution a lot of people would come to in terms of how to understand touch. But I think that a lot of companies have tried this kind of approach. Um, and I'm sure there's something hard about it that has stopped a lot of like the fact that this technology has taken so long or is like just coming about now. What's been so hard about this technology?
I think what's been hard, in especially in the robotics, field, is that sensors were bulky,
Yep.
expensive,
Hmm.
hard to calibrate, so hard to get actually repeatable performance over
Okay.
time, um, and you know, really just uh, low resolution. And when I mean
Yeah.
low resolution, I mean really low resolution. So what we're hoping at GelSight is that we are solving all of those issues. With the whether it's the digit, which is now something that is completely mountable on a robotic hand, right? That's
Hmm.
what it was designed for. With a price point of $300, that's what we announced with Facebook. It's available for $300.
Hmm. Or Meta now.
with Meta,
It's
I should say.
confusing, yeah.
Good. Yes, absolutely. You're absolutely right. And also, because we're imaging based, right? The resolution of our sensor is actually directly linked to the resolution of the sensor, the cameras that we're using, the
Yeah.
image sensor we're using. So, in the case of the Digit, I believe it's a VGA resolution sensor. So you're getting,
So for VGA, that's like
uh,
that's one of the display ports, and so is that 640 by 480 or what
correct,
was?
640 by 480, correct.
I don't know why I would know that, but okay,
Yeah.
yes.
Yeah, so suddenly, you have, million plus pixels to play with. All the other technologies out there will give you in resolutions in the tens or hundreds, of pixels for the same surface. So now suddenly you have this amazingly high resolution available to you at $300 in something that you can mount. So, now when you're starting to think about applications, I think you have something that is actually even better than the resolution of a human finger. So it puts things in perspective. I think our technology helps to bridge that gap that existed before. That's why we believe it's exciting. And for GelSight, we had also this reputation of being extremely expensive and big.
Yeah.
Our standard products are in the $20,000 to $30,000 a piece. But here we are. We are a company that's able to do things, for different applications, and this $300, sensor
Yep.
shows that we can do things at low cost.
Yes, and I want to talk about Digit quite a bit, but I want to still talk. I want to make sure I understand everything pretty well before going into that. So, one of the big things that was really hard with getting this into robotics previously was probably that the sensors were extremely bulky, as you were saying. Um, and so, how have you guys made it smaller? Like, how have you reduced the bulk?
It's a great question. The what really actually attracted me to GelSight is that at the core of the technology, which I described, and I think you have a good understanding of now, um,
Hmm.
the three pieces, you should think about them as a modular approach, a design approach. So we can
You
really
mean modular in that they can each be improved independently?
correct and then put back together as a system. So for
Yep.
example, to your question about miniaturization, we can design a gel material, a polymer material that is specific to an application like robotics, right? And actually make them in any X, Y, Z dimension that you'd like. It's almost infinite in design space, and then to that we can
Huh.
put in LED illumination, um, in a fairly easy way. These are not big, type of electronics, and then the challenge becomes more about the image sensor that you use, and most importantly, the lens and the field of view of the lens, and how close can you get it to to this elastomeric materials that we have. But you can
Yeah.
play with that depending on what the
Can you
application
say
is.
that word one more time really slowly? Isomeric, or what is it? As
Elastomeric, sorry.
elastomeric.
Yeah.
Okay. Okay. Yeah,
I'll try to
yeah.
avoid using it from now on, but that's
I'm
it's
just
part of
thinking clear
the
sil clear deformable polymer
yeah. It's a gel.
effectively. So it's a clear
Internally, honestly, we call it gel. That's
okay.
the easy way that we think about it. But then to your question, so what we did is that we basically found what is the right surface, contact surface that would be attractive to robotics applications, and then
Hmm.
how small, how thin can you make that sensor by playing around with the camera module basically and the field of
Hmm.
view of that lens, and that's how you get something like Digit in that kind of size.
Yep.
There are ways actually that we have developed at GelSight to make it even thinner. So Digit is not the limit of how small we can make things.
Yeah. Okay. So we keep mentioning Digit. What is Digit? Would you tell me a bit?
So Digit is a basically a tactile sensor. It's a digital
Hmm.
tactile sensor, imaging based. It's basically GelSight technology and then a Meta design. the Facebook Meta AI, I should say, sorry,
Yep.
has identified the need to really have this small, easy to integrate into robotics hands and fingers sensor to be able
Hmm.
to develop AI algorithms for a bunch of different applications, object manipulation, pose estimation, things like that. And basically, we are their commercial partners to bring that sensor to the world.
Yep.
We share the same vision. We believe that digital touch and feel is the next sensor to be digitized.
And we'll
But to do
definitely get
that,
into that. That's a very
right,
interesting thing.
and to do that, you actually just need to make it easy to use and affordable and small. So that's what we're doing together.
Yeah. So Digit is something that Meta AI, or formerly Facebook AI research, I don't know, organization, or the part of Facebook that does research and development for that. So they created this Digit and they open sourced it, correct?
Correct.
So it's freely available online. And then you guys now are taking this and building it at scale for this so that people
Correct.
can buy it and it's out of kind of the research lab and into the world.
Correct.
Um, what? So it was a research paper with maybe like a demo and this kind of thing. How long ago? How long ago did Facebook or Meta release this the Digit design?
I believe it's over a year ago. I don't know the exact date,
Wow, quick.
um, but over a year ago. Yeah.
And then how did you guys how did you begin a collaboration to um, work on this and produce it at scale? Like how did it occur that they produce a paper and now you guys are actually manufacturing lots of these?
Well, I think that's also a great question to ask Meta. But my
Hmm.
understanding is that some of the researchers at Meta AI had experience with GelSight during their academic research.
Ah,
And this is where they've learned about tactile sensing, they've learned about the GelSight technology, and kind of use that knowledge and gain expertise in academia, and wanted to actually focus on AI. I think more than building hardware, but such a hardware did not exist, and hence the need to design it.
and you mean it didn't exist because you guys have your product line, but it didn't exist in a way that was affordable to like put 10 of them on two
Correct.
robot hands, one at each finger's end, kind of thing.
Correct,
It would have been
and
prohibitively
in the right form
expensive.
factor as well. What
And
we
in the
had
right
was
form
way too
factor.
big. Correct,
Ah,
in our commercial
okay.
products.
So did they come to you and they were like, "Hey, we think it'd be really cool if you guys could work on this," or I mean, can you do you
I,
know these details or can you disclose them? I'm just
I,
curious.
the way I would answer this question is I would say we have a shared vision, and
Hmm.
it was very easy to align on this partnership because of that shared vision.
Yeah.
And I think when two parties basically have the same ultimate goal, which is let's bring tactile sensor to the masses,
Hmm.
and make it attractive for people to want to research with it, then the rest actually became really easy to do on an administrative part. And I
Yeah.
believe, and I hope that this partnership actually is just at its beginning, and more will come from it.
Yeah. So what is the nature of the partnership exactly?
So at the moment, it is really about GelSight commercializing the digit design, and that's already available for people to purchase through our online portal.
Yep.
Um, and really, that's the extent uh, of what we have agreed to do at this point.
Mm,
As I said, more is being talked about. I think now, that we've reached step one.
nice. What can you hint at what additional steps will occur or what they might look like?
Well, I think it's going to touch upon a few different things. One of them is we believe at GelSight that we can have a complementary offering to the digit sensor that will be attractive to the robotics crowd, but also to the hobbyist market. And this is basically aligned with our vision that, again, that we want tactile sensing to be available for any engineer, any technician, any hobbyist to use in their creative moments for anything. And I think to do that, you need to actually think beyond digit and just offer a more universal sensor. So, something that could be mounted to a robotic hand if you want to, but you can also use it as a digital microscope in a high school class.
Oh, that's cool.
Something like that, right? So
is that the kind of resolution you're getting with this approach, or?
Yeah, so what we're planning to do is actually having a much higher resolution sensor than digit, but at a similar or even smaller form factor.
Okay.
And our partnership with digit would be with Meta would be that we will probably want to leverage their open source community and make our sensor compatible with their PyTouch libraries and everything else like that, so that we have a kickstart. When people want to use our sensor, they already have libraries accessible to them right away. So this is where I see the next step being. So this is not something that is done today. Maybe it's I'm going to be scolded by my Meta friends that I'm already talking about something like this. But regardless of that, this is the direction we're taking, and this will happen because it's something that we at GelSight believe in.
Gotcha. And I want to talk a lot more about different libraries or ways of standardizing this. And it's quite cool if you make a sort of universal sensor, or maybe like a universal way of visualizing touch data and relating it. But going from actually creating, so you had, Digit was released as a paper. You guys agreed to start manufacturing them. I assume that since it was coming directly from the research community, that it wasn't built in a way that's exactly the easiest for manufacturing or the best way for manufacturing. Can you tell me a bit about those challenges? Because I assume you had to take basically what exists and then make it robust and make it reliable and make whatever grow it up for.
Correct. You're absolutely correct. It's always oversimplified. How difficult it is to take something that looks like you can make 10 of them in a lab, and now suddenly you need to be ready to make hundreds and thousands. That's exactly why I think GelSight was in the right partner for Meta, because we already know how to make products like these. We have an existing business. We know how difficult it is to do in volume in a repeatable way. So yes, we did have to learn on the spot really quickly about the Meta design, and then how to improve some of the manufacturability issues that we encountered as we were building them. But that was something that was expected. But this is also where GelSight's expertise is. We had some quick cycles of learning that we did in the early phases when you built the first ones to make sure that we have pretty high yield in building this gel material for Digit. Which
what do you mean pretty high yield in building this gel? It's like you have to manufacture gel and then you can cut it up, and you want it to be, I don't know, get a lot of it at once, or what do you? And some of it has quality issues, or
like anything, like any part of a product that you make, need to pass some specifications. And this gel material, which is kind of the secret sauce that we have, and we build it for different applications. You have to make sure that it has the right optical density that you want, that it's cut and in the right shape, and that the coatings are opaque, like we talked about before, to make sure that the light uniformity is going to be good, that you don't have an unacceptable level of cosmetic defects that will affect image quality, those kind of things. So this is what we're experts in, and took took us a few cycles of learning to get right so that we can start making hundreds of these or thousands of these.
Hmm. Okay. So it's interesting. I would expect that that's the case with the challenges of making a lot of them. Were there any particular things that came up that you know you had to change from the digit design?
And candidly, the biggest problem we had were component supply. In these
Really?
days, like I'm sure you've been hearing around
All the
us,
shortages.
shortages. And what was the challenge, I think, for both parties actually was to find replacements compared to the Digit's original component choices, just because of
Yeah.
supply issues. So I would say the biggest challenge we had was honestly around that, is actually finding
Supply.
alternate chips and things like that, qualifying them, and getting our hands on it. I think that honestly has been the biggest challenge.
Huh. What an interesting thing. So you had to like find it called for a certain part and you had to swap it and use something else
Correct.
and validate that it did the exact same thing.
Correct. Correct. And and develop the firmware because the original firmware was meant for another chip, so you have to make some
Yep.
modifications and that kind of stuff. That honestly was the biggest challenge. The rest of it was
Yeah.
okay.
Huh. Okay. So just and I don't think we've said digit is like how large is digit and what's its case basically? Um,
Oh, I think it's about, I
like
want
an
to
inch by
say,
3/4 of an
yeah, it's a
inch or
little
something
over
like
an
that.
inch deep.
Yep.
I think it's 28 millimeters if I remember correctly. Um,
Okay.
and
Just over an inch.
yeah, and I think I would need to get the specs on that, but I want to say it's maybe half an inch and a little bit over, maybe three-quarters of an inch
In, in width.
in width. Yeah,
And then in height, or then it's probably another inch in height,
yeah,
something like
slightly
this.
below
So,
that probably.
so it's kind of like an extra thick human finger
Correct. Correct.
in
Yeah,
terms of size, and it has a little pad on it that has um,
the gel
that
material. Yeah,
the gel material, and the gel material, it's kind of it's like framed by the case material, correct? So you put something on the gel material, and it will measure the deformation there, but
correct.
there's the edges on the same side as the gel, correct?
Yeah, there is a bezel. I think the bezel is like 1.5 or 2 millimeters.
So fairly thin.
Yeah, and the gel itself is, I forgot what it is, like 3 to 4 millimeters, probably high, um,
Huh.
in kind of a slightly dome-like, shape, just like your finger would, basically.
Yep. Yeah. So, yeah. Like the tip, like the last digit of your finger,
Correct.
kind of thing. This
Correct.
part.
Yeah. What's another thing maybe that would be interesting to you? The way I look at these tactile sensors like Digit is almost
Hmm.
thinking about having a camera inside your finger. So
Yeah.
imagine if you had a camera inside your finger and it would actually be able to see anything that deforms your skin as you're touching things. That's pretty
What a
much
crazy
what
thought.
Digit is,
Yeah.
you know?
Uh-huh. So just so I can picture the internals of it a little bit. So you have the gel surface,
Yep,
and if so, then we have the camera, and the camera could be so if the sensor is facing down and the gel is at the bottom, the camera is above, looking at the gel.
correct.
Um, does the camera touch the gel, or is it just like a sensor pad that touches the gel, or how do we get our?
No, the camera is offset from the gel. The gel is mounted, think about it mounted on like a plastic window, if you like,
Okay.
and the camera is behind that at a small
Ah,
distance. You need to have a minimal, distance between the camera and
yeah.
the gel.
I was wondering if you could like use the gel as a lens or something like this, but I imagine because it's not like a pinhole camera, you would get a lot of light going and bouncing all over, so it'd be like a very blurry image
Yeah,
as opposed to a crisp image for this
correct.
kind of thing. So you need that separation as opposed to not having a lens, I
Yeah,
guess, or having
and,
the sensor pad directly
yeah,
connected to the gel.
and you need to be able to image that area, right? So you need a little bit
Yep.
of distance to be able to see that surface.
Hmm. Now, for robotics, just like wondering, how do you connect to it? How does it work as a sensor? What exists for libraries? Like all these things. Um,
Yeah, so connectivity is done through a USB-C type, of
oh, nice.
connectivity, and then you basically
Did you
have.
need high data flow or something through USB-C, or was there any reason to choose it other than it's a nice port?
It's the most common port, and also robotics actually does care about real-time information,
Hmm.
and so you can run it easily at 30 frames a second. You know, um, it has even the capabilities, I think, to run a little bit faster than that. But you want to have real time, and USB is basically a good way to do that.
Hmm.
And then you basically program the sensor using all the firmware that Meta has made available on PyTouch. That's how basically you connect it to your computer, have access to all the PyTouch libraries, and
Yep.
you're ready to go.
What? So I don't know too much about the available libraries for this. What do they let you do? Like, I assume you can get 3D deformation, but is there like, I mean, there's for vision, for computer vision, there's like OpenCV or Open Computer Vision Library. I believe started by Intel,
Hmm.
and it's a big open source library. It's been around for a long time, and so that lets you do a lot of basic computer vision things. So if you're working with a camera, like almost right out of the box after you figure out the install, you can like detect faces or do object tracking or something like this. Is there any such things that let you kind of identify what you're touching or identify properties of what you're touching yet
Um,
in these
it,
libraries?
I think the meta team is kind of adding things on a regular basis, but some of the basic things you get are, for example, the ability to just see an image. So it's even a 2D interpretation of the image or 3D interpretation of the image.
Mm-hmm.
See where the sensor has been touched. So in if you look at the surface area of the sensor, which area has been touched, which is an interesting information, in robotic application,
Mm-hmm.
that they typically call pose estimation. Um, and from that's the kind of the very basic information that they give. The purpose of Meta, as far as I understand it, is to then turn this into creating data sets of deformations of that gel based on the type
Hmm.
of objects that the robotics hand or gripper is manipulating. So you kind of train models to say, let me grab this for example. If you say this is a cable, right?
Yep.
And you basically have your robot kind of holding it in all kinds of different you know orientations and different forces and things like that, and all that is captured in their data sets, and it's used to basically create AI to basically say, well, this is how I recognize that this is a cable,
Huh.
touching the sensor, and then can you do things like that? For example, like reorienting that cable in space because you want to move it from A to B, those kind of things. So I
Yeah.
you know,
To me, I'm seeing it similar to like image segmentation or something like this. So we do all of the when we had like ImageNet or some sort of thing that has a bunch of labeled images. So we have cameras. The cameras take
correct.
pictures, and then we say, okay, that's a cat, that's a tree, that's a whatever. And then you do that a lot of times, and then maybe one approach is you can have a more complex image, and you can identify the different parts that are in it. And I think now they do that typically with like bounding boxes that they just slide over the image or something to try to figure out where in the image might be a cat. But they're getting more and more sophisticated, and I'm definitely not aware of this, but or aware of the like cutting edge of this research. But it seems kind of like that, where the intention is to start with very simple identifications of things, and then perhaps eventually the robot can grab a chunk of stuff from a messy desk and identify that it might have a few cables and whatever, so it could look for things or
I think you're right.
something.
I think the holy grail is actually to be able to provide that kind of intelligence to robots the same way that you've mentioned about image recognition, for cats and dogs and other things, right? It's kind
Yeah.
of the same idea. Is if I want to be able to do complex object manipulation in a robotic application, or to do kitting, right, and other things like that of small
Do
objects.
what?
To do kitting, for example, if you want to take, you have a box with a whole bunch of different objects. You don't really know what those objects are, but you want to basically put a certain class of objects and put them in another box, but this time classified by the type of objects. This is something
Yep.
that's actually very difficult to do.
What's the word? Kidding?
Kitting, yes.
Kit?
Like a kit, kitting. So
Like you're assembling kits kind of
correct.
thing?
Correct.
Ah, okay.
So
I've not heard that before. Okay.
yeah, so
So if you're grouping objects by type or something,
for
and
example,
yes, go ahead.
the other thing could be if you're trying to just assemble things that today are really only done by humans, because humans have the kind of dexterity that you need to do those kind of complex assemblies. Handling cables, or handling types of fibers and things like that are just really hard to do for a robot. You need to have that kind of sensitivity, feel that humans have. So providing this kind of perception capability to robots may allow them to start doing some of these more complicated tasks.
Gotcha. And I imagine that it's not terribly interesting to be like, okay, now we can grab this and identify it as much as it is that you can use it in like a sensor fusion kind of context where you say, I think that I'm grabbing this and I grabbed something. Does it agree with what I expect to feel given this? I think that would lead to more interesting applications of this kind of thing.
You're absolutely right. One thing that's really interesting is that machine vision and computer vision is extensively used in robotics today. But one thing that happens is, especially in a robotic hand, for example, is once the hand grabs something, you can't see anything. It's occluded.
You have no idea what it is.
Right. So I think complementing vision with tactile information is something that's going to be extremely useful.
Yeah. Now, so one thing that I'm wondering as a roboticist with this is, so say I want to like screw in a screw with this. So I want to pick it up with my fingers and I want to screw it in. So maybe I can pick it up and identify it. But I think that I'm imagining the gel is quite soft for this. And that deformation might make it hard to control whatever you're picking up. Is this would you think that this is correct? And are there strategies for using these sensors with tasks? Do you like identify it and then move a little lower in the end effector or higher so that you can identify what it is and then pick it up with rigid grippers that you kind of know what you have? Or is it more complex in how you grip it?
So, first of all, the gel that we use in robotics application today is actually not that soft, at least not to the human touch. It's actually, it would feel, it will have this kind of elasticity feel to it, but it's still pretty hard. So actually, if you're grabbing, a screw, for example, as you mentioned, you would actually not really need to, pass it on to another robotic arm to do something else. You actually will have a very good understanding of what the screw is. How hard you actually grasp it will actually give you more information about its shape. We actually have done some experiments that you might find interesting to use our tactile sensor as a hardness, a relative measurement of hardness, because similar to human skin, right, and human finger, if I'm pressing on something that is really soft, I really don't have a lot of feedback on my skin. It's actually very, very light. But if it's really a hard material, my skin will get indented really fast. Well, it's the same thing that happens with our sensor. So when you're holding an object and actually pressing it against another, it actually also gives you that really interesting information about the potential hardness or softness of the object that it's touching. So it's
So you
really
look at the deformation of both objects, the gel and the object, to kind of infer the hardness of the object. Is it
the gel
correct?
by itself would tell you how hard the object is that whatever you're holding is in contact with.
Huh.
You know, just by again, you know, just imagine we have a video I think on our libraries of a gripper holding a fork, and then we have hardness samples. And as you push the fork into the hardness sample, you see how the tactile sensor deforms depending on the hardness of that sample. And the harder it
Hmm.
is, and the more it deforms, right? So that's actually how you
Yes.
get a relative hardness measurement.
Does this require that you have 3D knowledge of whatever the object is that you're doing, or at least you know, like, say, the width of it, or how far it is between the two sensors, or how much of it should be pushed into the sensor?
I think 3D helps, but I don't think it's even necessary.
Oh,
It's
okay.
I
I
think
don't
it's
intuitively see how it works then.
well because you know all we really care about is you know for example is the depth of the indentation, but not necessarily the exact shape of the object. You know, is how deep do you get into the gel deformation, for example. But if you have the shape, then you can also say, oh, now I'm starting to recognize that that's the tip of a fork, for
Hmm.
example,
Yeah.
because you can add that to object recognition.
So you think if we're picking up like a screw or something, and we have, say, you have the two digits or whatever would be next after digit with higher resolution, and you have it between the two sensor pads, between the gel on both of the sensors. Now you can kind of see how it is pressed into both of the sensors, and you can infer in 3D how the screw is oriented
Correct.
with respect to the sensor. And then from there, you can figure out how it's oriented with respect to the rest of the robot, because you know how the fingers are positioned with respect to the rest of the robot. This kind of thing.
Absolutely. That is possible today. We actually have we're doing that at GelSight. We build basically a 3D point cloud model of an object that we want our grippers to manipulate. And
Huh.
based on just the contact area, we actually able to infer the orientation in 3D of the 3D point cloud,
That's super
which is a
cool.
really cool thing to do. Yeah.
So when you say point cloud, you mean mesh kind of thing. So it's
Yes.
not, you're using your sensor to get the 3D information, and it's creating like a mesh representation of the object, like you
Yes.
see in like a 3D graphics. But
Correct.
I was thinking LiDAR initially, which you get all the points, and then you can
Yeah.
infer 3D
It's
from that.
yeah. I think a mesh is a good explanation to it for it.
Gotcha. Just making sure I understand.
Yeah. No problem.
Okay. Then, so do you know what Meta, or formerly Facebook, like, so I know they had the one robot that would turn and look at you, and it was used for like video calls and things like this, like an Echo with a neck kind of thing, Amazon Echo with a neck. Do you know what their interest is in tactile sensing and fine manipulation? Are they going to get more into robotics, or any ideas here?
I think it would be a
Or is it
bit of
just their research
speculation of
side?
my side. Well, it's definitely started as research, but I think
Yep.
the idea of providing this intelligent perception tool to robots is what is compelling to Meta. As you imagine, robots being able to do more and more tasks, um, it became obvious to them that it needed to have additional sensing capability, and that vision and sound was just not enough for robots to be able to do the kind of complex tasks that a human does. And I think in their very grand vision, I believe that robotics has a place in their metaverse story, in the sense
Hmm.
that you have to
By
imagine.
metaverse story, you mean the kind of 3D world they're creating?
Correct. I think I look. I define. I have my own simple definition of metaverse. It's really basically the integration of the digital and the physical space into one. And to do
Okay.
that, you want to have the ability to replicate or duplicate any task that happens in the physical world in another world. And robotics is part of that other world, although it is a physical object or equipment. You want it to be able to replicate what humans do, to provide services just like a human would do. So if you imagine, for example, doing remote collaboration through a robot, or somebody who's coming to a robot coming to your house to do house cleaning, or to be your the person that's actually bringing you water if you're incapacitated in bed or
Ah,
something because you're sick or something. Well, if you don't have those capabilities, I don't think you're going to be able to perform those kind of tasks like a human would. So in that perspective, I think this kind of research is probably very attractive to them in the long run.
is there work on kind of the other side of this where it's so right now your sensor allows you to get really accurate um, 3D deformation information. So you can push an object into it, you can see the surface. Like the videos or the pictures are amazing, like where you see a fingerprint or you see the $1. I think I saw this somewhere where you see like a $1, or if you put it on a $100 bill, you can
Yes,
see the press
correct.
of the, like that's crazy.
Yeah.
Um, but is there work in the other side of this where, okay, we have this detailed 3D information, can we display it elsewhere? This kind of thing. So like if I push into it and I feel like say my finger drags across a larger one of these sensors, can that be replayed in a 3D space some other way?
So I think
And I
you're
know it's outside of what your company does,
well,
what
not
GelSight does,
not
but
completely, because I
oh,
think what
okay.
you just described is, I mean, to me, and tell me if I understood correctly what your question is. Um, I look at tactile sensing being the input to another output, which is haptics, right?
Ah,
So what you
yeah.
just described to me is, okay, if I know how it feels, right, to touch it with my sensor, I give you a digital signature of that texture, of that feeling, right? So what do I
Hmm.
do with that? And I think what you do with that, one of the things you can do with that, is actually that becomes the input that you need to have true to life haptics experiences, right? Because
Hmm.
if eventually one day haptics technologies would be just as high resolution as our sensor technology,
That'd
and
be crazy.
they're gonna need, right, to know, well, how does wood grain feel? How does cotton feel? How does that silk feel? How does glass feel? And I don't see how you get that information without a sensor like ours, which gives you millions of pixels of information to derive a digital signature of any texture out there. So when you
Hmm.
think about the need one day to have a digital twin of all the surfaces in the world, or all the feeling, the textures of materials in
Hmm.
the world, you're going to need to characterize them through a digital tactile sensor. And
Yeah.
that's going to be very useful to people working in haptics, in my opinion.
Gotcha. The combination of those. So if you go from good texture sensing to haptics, that makes me, or that to me with meta makes a lot of sense. It would be kind of like Ready Player One or something like this,
Yeah.
where you have like sensations and stuff.
Yeah, I think we're kind of the microphone to the speaker, if I use the sound analogy, right?
Okay.
And I think in our world, we're the input to haptics. I think that's
Yep.
that's just a simple way to look at it.
Yeah.
We're the camera, we're the camera to the display. That's how I look at our company.
Yep. And so now you mentioned at the beginning how the digitization of touch. Can you tell me a bit about kind of what you believe are the implications of this and how important it will be and how technology will go that way?
Well, we believe at GelSight that honestly the next sense to be digitized is touch. Vision was first, and we know what happens once CMOS sensors became broadly available. Not only
Yeah,
obviously
and
it helped to
that's what they're made out of. What is it? Complementary metal oxides?
oxide,
I don't remember.
yeah,
Oxide,
silicon,
whatever.
I think,
So,
metal oxide.
okay, so that's what those are made of.
Yeah, but
Uh,
those basically it translated photonic information to electronic, an electronic signal,
mhm.
and you know, and today it's used.
So we could get digital images as opposed
Correct,
to like the
correct,
old, I don't know, film roll
correct.
cameras,
Like the
this kind
really
of thing.
original, picture taking technologies, that you know, uh, with the silver oxide things, and that Kodak
Yep.
was famous for a while. But
So we digitize that,
we
then we could
digitize
put it on
that,
the
and then we
computer, make
basically,
infinite copies.
yeah, you can make, so first of all, you'll be able to miniaturize it, make it widely and broadly available to everybody to be able to take pictures, videos, and so on. But most importantly, it actually allowed computer vision to take off, because now you have access to the billions and billions and billions of images to be able to derive information from, using machine learning and deep learning techniques.
Hmm.
And then audio went through the same revolution. Without digital audio, there would be no speech recognition, and no Alexa, no Google Now, no Siri, no music streaming, like no Spotify or anything like that, no Apple Music.
We'd have our record players, and that'd be it.
Yeah, which I liked a lot.
Which
And
use analog.
exactly,
Yeah.
it sounded really good. But none of these other things would have happened, because now we have, again, trillions of hours of sound and audio bits that can be used for algorithms to train and respond to. The next,
I'm surprised. I'm surprised that video or images came before sound. To me, it seems like sound is simpler because it's one-dimensional as opposed to images. But I mean, I guess we've been interested in cameras for a long time.
well, the human brain, 30% of our brain activity is used by the
Yep.
visual cortex, right? So
Hmm.
I'm not surprised that we were more attracted to sound, to audio, to video, sorry, than sound.
Yeah.
Uh,
Gotcha.
but I think the next one is really touch. We are multimodality creatures. Then, for humans to really do what they do best, they need all of their senses.
Yep.
And the next one that I think is ripe for digitization is tactile, or touch and feel. And I think
Hmm.
it's going to open up a brand new type of applications. Starting with robotics, but also some of the other activities that we've been doing at GelSight in understanding surfaces and features of surfaces for years now.
Do you want to mention some of the other applications that use this technology?
Sure. I think at a really high level, we have found that we are a really nice fit whenever we count an application that has been using actually human touch. So, believe it or not, in aerospace, for example, there are still some companies that are using the fingernail test to decide if a scratch on a part is a problem or not. A problem basically meaning that it needs to be reworked or tossed. By
What
basically
is the
just,
fingernail test?
well, basically you put your finger in the scratch and you actually feel how deep it is. Like you say, well, yeah, that one I think is too deep. We need to do something about it.
That's crazy.
It is crazy, absolutely crazy. But for us, using our sensor, they're able to get now a repeatable, accurate, fast measurement, quantitative, not subjective, and you can make
Yep.
decisions right away that are the right decisions every time. And our technology is the only one that allows to do that, because vision is not very effective on metallic surfaces that are hard to take pictures of. It's very highly reflective, and so on. And again,
Oh, definitely. Yeah.
right, the beauty of our technology, because it's touch the same way as human touch, it doesn't really care what the surface properties are, whether
Looks
it's
like. Yeah.
glass, metal, transparent, translucent. We don't care. Reflective. We our sensor would deform to any material. It doesn't really matter. So this is where we have typically seen success, and our initial commercial efforts have been around providing measurement capabilities to companies that are interested in understanding specific features in their applications, like scratches and dents in aerospace, or measuring coatings in the paint shop in automotive. I mean, it's basically any time that you have, I think, human touch being used, or where basically using a traditional camera system, just not going to work because of the type of material that we're dealing with.
Yeah, shiny ones, metal,
Shiny
as you
ones,
mentioned.
exactly.
Huh. Okay. Yeah, that'll be cool if touch becomes digitized and then we have a way of communicating. And then it can maybe enable all the haptic stuff that we were speaking of earlier, which would
Correct.
be really, really cool.
Yes, I've tried many of the current haptics technologies, and it's just a very disappointing experience. It's basically, vibrations you feel, regardless of what you're supposed to be touching in a digital form, and
Mm.
that's I think past the first second of, oh wow, I'm feeling something. You actually just say, yeah, but that's not how it's supposed to feel. So, and they have really no other way. I think today, all I've seen is varying the frequency of whatever technique they
So
use,
you'll
whether
grab
it's,
a pen or something and it will, you drag it across a surface and it kind of spoofs by putting forces in it that
for example, or if it's a
what kind
haptic
of
glove,
frequency you
right?
might see.
If it's a haptic glove,
Yeah.
sometimes they have, kind of vibrating membranes on your tip. So you
Yep.
basically change the vibration, you feel that you're touching something.
It's a
Um,
similar approach to like how sound works, right? Because I
yeah,
mean, with the digital sound, you represent different frequencies, and then you combine all those frequencies together at their respective amplitudes, and then you get the appropriate sounds. Um, so
yeah,
it's kind of like that. They're emulating that, but in a touch space.
correct.
And you're saying at the current moment, it's not very convincing.
No, it's not at the resolution, and it's not actually matching what it's supposed to be.
Are there any technologies that you know of in this space that are promising? Or maybe we get the really good touch information, and then that'll help us have, I don't know, we'll use that good information to build better emulations of what they look like, this kind of thing.
I'm not aware of. I mean, I'm aware of a lot of companies working on it. So I'm sure that progress will be made. It is a difficult problem. I haven't seen anybody who cracked it yet.
Yep.
But I do hope that the digitization of tactile sensing will help haptics companies because it will provide them with, a library of how things should feel, and I think
Yeah.
that's an important part of it.
Huh. Yeah, that'd be nice. That it feels like so. I'm not very aware of much research in the haptic space, but a lot of it seems to be like, can we emulate this texture, or can we classify this texture in a good way that we can possibly emulate later, and this kind of thing. And if you have really good information there, then that, I mean, especially like if I'm a researcher that's trying to do haptics things, and I go use one of your sensors and generate a whole library of what, like, say, a wood grain looks like, and then from there I can randomly sample, um, or I don't know, build a model based on all that data that I just took myself, which is really awesome.
Right. And one thing that I think also might help to accelerate the adoption of digital touch, I think, is also the use of this digital understanding of a surface for applications like um, let's say I'm a textile company, I've designed something,
Mm-hmm.
and in the US I'm having it made in Southeast Asia. And one way to verify that what they've made is exactly what I want is actually to compare the digital signature of it,
Oh, that's super cool.
right? Which today they don't really have. I think the only way they really do it is by exchanging samples,
Huh.
right?
So you're
Hey,
saying, like, if I want something from some company and I say it has to be made to my specifications, and they say, "Oh, I've done it," you can say, "Oh, I've padded it everywhere, and I see that the model is, I don't know, not within tolerance in this one dimension, or the wrong shape, or whatever it might be, something like that." So you can verify
you would verify the
the,
texture exactly. Does the
yeah.
texture match what I designed, right? So I'm
Huh.
designing it here. I want the texture to feel this way. Here's a digital picture of what that texture should feel like. Build it, and then measure the digital signature on your end and see if it matches.
Huh. It'd be cool if this was also used for like counterfeits and things for like say like a high-end clothing brand. They're like if you press your device on it, you can see the quality of the fibers versus polyester version that looks similar or
Well,
something like this? Because I imagine you could look and see the differences.
you're absolutely right. We actually had inquiries around exactly that front because
Really?
because the thread count, is different,
Oh,
potentially. Um,
huh.
counterfeit material, counterfeit shops are becoming extremely good. It's
Yeah,
basically becoming very, very hard to tell, true from fake. But one way actually is to get a digital signature of what it's supposed to be like.
and look at it.
Yeah,
Yeah.
so it is part of our vision. For us, if we could find a way to build a product and the software behind it to provide to all of the custom offices out there that wants to verify, you know,
Hmm.
um, uh, is this real or is this fake? And they basically could scan the materials and say compare it to their database and say, well, this is how the real one is.
Yep.
That is
Shouldn't
just
look like that.
a much more efficient way to do it.
That's super cool. Do you also, I'm imagining applications in healthcare and this kind of thing, like, oh, I think I have a lump here or
Yep.
something,
Yep.
and you could press it into it and you could maybe get good 3D information about what you're seeing and then what that means for this kind of thing.
Absolutely, and we've had again in the history of GelSight, we've had inquiries for such applications.
Yeah.
We haven't really pursued them at the time. For a small company, you do have to choose where you want to spend your
Oh,
your
yeah, I
R and
should have
D
asked,
efforts.
how
But
large are you guys?
we're only we're 20 people just about today.
And how do you do most of your, so it's been up until this point where you're doing Digit, which is, if I understand correctly, it's like the first fairly low cost
Yep,
sensor that you guys are making. So it's been low volume, high margins
correct.
um, on how you've been operating. So extremely, and so you probably assemble in house and this kind of thing,
So
um,
I would say our
or a
chemistry
mix.
type of
Yeah.
work. So anything around the gel is done in house today, but we have started to outsource some part of that process, and then the
Hmm.
electronics assembly piece is outsourced. So we don't do that in house. So we've been preparing ourselves for scale, and you can't do
Yep.
that by just assembling that in our office in Boston. So um,
Yeah, definitely.
we've already started to build that supply chain.
Huh. Interesting. What do you how do you imagine growth looking for you guys? Like, what do you think in the next like 2 years, 5 years, this kind of thing? I know it's a projection of something that hasn't happened, but like, what do you think?
Our focus in the next couple of years is we just launched our Series 2 metrology product. So we're kind of putting our commercial efforts on the deployment of that solution, which we just launched this October. And then we basically planning to push the commercialization of Digit, obviously, which is something that is important to us. And then this next generation low cost sensor that we'll hopefully have in the first half of next year. But
And
the thing
that's the one
for
you were saying that would be more accurate, smaller,
correct,
perhaps, than this kind
correct,
of thing. Okay.
correct, because the thing is we need to create an ecosystem around tactile sensing, and that's
Hmm.
again the shared vision with Meta, and to do that we need to invest in um, bringing products that are in that kind of cost point and ease of use and form factor, and also invest in marketing, to make it known. Um, and that's what we basically we're focusing the next 6 months to a year is let's make tactile sensing
More of a thing
available,
that everyone knows
that
about
everybody
and
knows
can
about it.
use.
Everybody who has any kind of curiosity about what can I do with this, we want to remove all the barriers, all the obstacles, and make it easy for them to get it.
Yeah, I'm seeing Digit. Were you guys similar to what was it? Is it Lepton, the FLIR, the
Yeah,
thermal camera,
yeah,
where it's like they made I think it was the FLIR and it was the fairly low cost
yep.
thermal camera. Like I don't know, it was a few $100s, where previously they were very expensive. So are you following kind of a similar business model? You think at the moment with Digit?
Yeah, I think it's actually makes me smile that you're mentioning the Lepton camera. I actually worked on it in my past life, but
Me
but
too.
um, Yeah, I think
I
it's
worked with it, not on it.
yeah,
Yeah.
yeah. Um, so yeah, I think it is about building that community. We want to make it available, we want to make it affordable, but at the same time, we need tactile sensing to be, used in real applications by customers that give us that market credibility, right? When I work with a company in aerospace that is actually saying using your technology saves me hundreds of thousands of dollars a year in reduced rework cost or maintenance cost, that is very important for a GelSight because they basically said tactile sensing is not only about a long-term dream, a long-term vision. It
Hmm.
actually has applications today.
Yep.
So we are continuing to work hard at having our sensors being used in real applications, but at the same time, we want it to be, we want to create that community that hopefully is going to be very really large in the years to come, um, that will consider the use of tactile sensing in their future products.
Hmm.
And to do that, we need to continue with what we started with Digit.
What kind of software push are you guys doing? So I know that Meta AI is contributing a lot in the software space, it sounds like.
Yep.
But are you guys maybe making libraries that expose the data type and make it useful for a lot of common applications, a lot of common hobbyists or makers, this kind of thing?
So for the I would say the low cost part of our portfolio, we intend to follow the Meta example and make libraries open source, make them easy to access.
Does
Um,
anything exist yet, or it sounds like it doesn't yet?
we have a few. We already have our 3D reconstruction um, uh, technique, can be available for people to leverage on our sensors. Our pose estimation, algorithms also.
Hmm.
We have we're thinking about other things. We have anti-slip, for example, for robotics, which could be interesting. Detecting that an
What is
object
it?
is anti-slip,
Yeah, I was going to ask about that
right?
actually. Okay.
Detecting that something is slipping from your
Yep.
grasp. So these are all the things that we, can put
Huh.
available for community to use. So we have a few, but we need to accelerate that, and as part of our plans. So on the low end side, I would say we're going to follow the open source model. We're going to try to make it everything that we
Awesome.
develop, make it available for the community.
And part of that is growing the community. Is
Correct,
that gotcha?
correct.
So it's interesting that that's a pragmatic choice, which is quite cool to me. As someone who really likes open source, that it's kind of a pragmatic choice
Well,
to do open
it's
source.
very pragmatic in the very in the sense that that ecosystem today does not exist. It's
Yeah.
very small. So for us to grow it, it would be, I think, it would not be smart of GelSight to make it difficult by having a closed source
Yeah.
system, or make it onerous for people. So open source is the way to go to create a community, and we are definitely embracing it. Now on the higher end, type of product, there we are, continuing to develop applications, and those are included in our software suites that customers are, paying for,
Hmm.
whether it's with the purchase of some of our systems or as just an application suite, just like you do with enterprise software. But even
Yep.
then, even there, we are planning to also invest in, machine learning and AI to bring in more services to our customers in the future, where instead of just offering a tool that provides them with a decision-making capability at the instant, is also the ability to leverage the data that's coming out from these sensors over time. So as you're building a
Mm.
database of images in an enterprise environment, do something with those images over time. And we think that machine learning and AI can help us bring more value to our customers, and that's another part that's going to be important for GelSight going forward.
Do you mean keeping it for yourself or putting it out into the community? So you get a bunch of data and you can train machine learning models on it or whatever it might be. Will it be like you'll release a public data set, or you'll keep it
I think we'll
in-house
do
and or
both. I think on
oh,
the consumer like market, we will likely publish some public data sets, to
oh,
help the community leverage those data sets. But in the enterprise space, when you know the problem to solve,
yep,
there's a way to just monetize directly that data set by building
I
services with
see.
that.
Do you think are you guys do you think I mean, I have so many questions around all these different things because the software and the open source side is really interesting. But so one of the things that really kicked off the um, all of the advancement in computer vision, as far as I understand, is like the release of ImageNet, and I think it's ImageNet. It might be some other thing, but it was a big data set with benchmarks, effectively, for you can compare how good your algorithm does. So you have a bunch of images. Those images are labeled, and it asks you, "What is this?" And then you can run your algorithm on it, and your algorithm is right, say 60% of the time, and the current state of the art is 70% of the time, and you know how what you're doing compares. Do you think it's in your future to create anything like this for a touch
I
data
hope
set?
so. I really hope so.
That'd be awesome.
It's a very ambitious goal for for a company of our size today, but it is part of our story, and it is part about how we
It's
want the
true.
company to grow. And we believe that that is something that needs to happen, and that we hope that we'll be the ones to build it.
Yeah. If I remember correctly, ImageNet was done by Fei Li, and I think she was at Stanford. And so they just received a big grant, I think, and then went and did it. Um, so I don't know, something like that. I may be wrong about the story or who or anything, but it'd be quite cool to see you guys do a touch library that would really accelerate this whole space.
Agreed.
Um, are you doing anything? So I mean, I'm at Open Robotics. I'm wondering, do you have ROS? Like, do you have any way to interface your
Oh,
software with
yeah, I should
the
have
robot
mentioned that.
operating system?
I should have
Ah,
mentioned that before. Edward, sorry.
no,
We
it's okay.
actually our sensors and our software and firmware is ROS compatible. Um,
Sweet. Which
so
ROS, by the way? Are you
uh,
using ROS 1 or ROS 2?
I don't know. That's a good question. I'll ask my robotics engineer. But it is absolutely our that's that we intend to support anything that we need again to accelerate adoption. So ROS is definitely something that we keeping an eye on and
One
supporting.
thing, if you yeah, one thing that would be cool, if so as you are working, so if robotics is a big interest, and a lot of the robotics community uses ROS, um, one thing that's very nice to have is something standardized in the ROS community, and the way to do this is through a ROS enhancement proposal. It'd be very cool to create one of these for like a data structure that's really good for touch. But actually, maybe it's just an image, which is kind of nuts, or like a 3D point cloud or something like this.
Hmm.
But if it is a non-standard data type, creating one of these ROS enhancement proposals would be really cool. And then we have this as like this is the de facto touch type that will be used in the ROS ecosystem. So other packages can also use it and build off of your standards.
I'm
I think
making
that'd
a
be very
note.
cool.
I'm making a note.
Awesome. That would be super cool. And I'm happy to see that you guys are already supporting ROS. Even I wonder if it's ROS 1. A lot of people are moving to ROS 2, which is quite cool. It's getting steam.
I can ask right now. I don't know if I get an answer right away, but
Ah, I mean, it doesn't matter too much.
yeah.
Let's see. So now let's see how much time we have. So we have like another 15 minutes or so. Um, so one thing I was really curious about your sensor was vibration. And so a lot of time, or as far as I understand, if you have like a gripper and you have an object in it, and the object is starting to fall out of the gripper, it'll create vibrations. So you'll be able to sense vibrations or something to know if the object is slipping, which you've mentioned.
Yes.
Um, and I was wondering with the gel how this would be. Like perhaps if the gel deformed and then slowly came back, it would be very hard to get vibrations, or if it was very springy, it might be easy, or you might get a bunch of noise if it's too springy back. I don't know. Can you talk a bit about the slip of different objects through your sensors?
Yeah, I think, the really, I think what we do is we have come up with a way to measure the local forces at the sensor surface. And, based on that, you basically,
So you just assume that it's normal to the deformation.
yeah, so
Like you have a deformation surface and the force
correct. So
is
what we do actually,
normal
we,
to it.
we imagine like you printing a dot matrix on the membrane of the sensor, right?
I don't know what you mean dot matrix.
It's basically a matrix of black dots, right?
Oh, okay.
So
That's what you mean.
right,
Okay.
yeah, and
I was thinking like
and
dot product, like in math or
no.
yeah.
It's just
Like,
very, yeah, just exactly what it sounds like.
so you put
And
a bunch of dots.
yeah,
Yeah.
and so now when you have a camera, right, every time that you press on the gel, those dots, location basically get changed based on how the surface is being, being touched, and based on that, I actually have now an idea to know what is the local force vectors basically on the entire matrix. And
Hmm.
as you're moving across the surface, I also can detect basically the changes in those local forces. So if your object is starting to slip a little bit, then you basically see the vectors kind of all going into one direction with the relative intensity also showed, and you put all of that together, you're able basically to detect that the object is actually starting to slip in some way.
Hmm.
So it's a pretty neat way actually to provide this additional information. And one of the key
Yeah.
things, you're a much better, much more expert than me in this field, but um, one of the difficulties, as I understand them, in trying to get force estimation in robotics arms and fingers, is actually that the sensors that measure forces are not at the tip of the
A lot
hand,
of
right?
times.
A lot of
Yeah.
times, right? So this is, so when you get
And
force estimation,
this is specifically a problem when you have like a high gear ratio. If you have low gear ratios, a lot of times you can infer the force at the tip pretty accurately. But if you have a high gear ratio, there's all those gears in the way, and I don't know,
correct,
whatever it makes it so it's hard to do.
correct.
The
But
back
in
EMF
our
is
case,
noisy or whatever.
in our case, we actually can provide you with
A
local
really good
force estimation
estimation.
at the tip, which could be also
Hmm.
very interesting depending on the applications.
So for the local force estimation, at least with the digit, it probably can't. Like if I'm imagining like I had a robot that was like going to pick up something with a forklift, and I
Hmm.
wanted to feel what's on the end of the forklift. Um, I imagine you can't put a lot of weight into these sensors. Yes, so you're shaking your head. But is there any way to make them more robust? Because like if I'm trying to grab something that's heavy, I probably can't use these sensors on the end of
Yeah,
whatever will grab them.
I would say, you saw you shaking my head there because in the case of digit, right, if you're putting uh, very heavy weights on a hand, equipped with digit, I just think that I think the mechanical housing would just crack.
Crack.
That's
Yeah, that's what I would
it was
imagine
just
too.
not meant for that. I don't think the issue is really the gel as much. But the key again, as I said very early in our conversation, you could design, the sensor for different applications, right? So if you're
Hmm.
basically looking at an application where you need to apply a lot of force on the sensor,
Hmm.
then you can design a formulation that allows you to do that. You can also design, the thickness of the gel to be, maybe thick enough to allow for, a lot of pressure to be applied, or thin enough to
Hmm.
be able to apply a lot of pressure. So we actually have done that. We
Hmm.
we have a customer in forensics who we're
That's
doing
super
some,
cool.
yeah, which we're doing some tests with,
Forensic
right?
like
Yeah,
crime scenes.
absolutely. Yeah,
Oh, that's super cool.
they basically use our technology to measure bullet casings and compare them to a central database to basically be
That's
able
wild.
to provide like a biometric, confirmation that that case came from this gun. With a 90+% confidence. It's actually used in in trials and in crime labs and things like that. So it's
That's super
pretty
cool.
pretty wild. But in that particular application, they use more of a benchtop type system from us. But they can apply 6 to 10 kilograms of force, very locally, very super localized in a small area. We've done some tests on some other things, where we go to 15, 20 kilograms of force, again, in a very, very, very tiny area. So I'm not, I think our team could design things to be, used in applications where there's a lot of weight applied to them. It just needs to make, business sense, to be honest. I think that's really the main
The
challenge.
main limiter. Yeah, gotcha. What about a sensor without bevels? I'm thinking about it. So you have currently the edges around the gel pad. I'm wondering, like I imagine for robotics, it'd be really nice to not have those edges because you're limited. If I'm trying to touch into a hard surface, does the gel extrude a little bit past
Yes,
the bevels?
it
Oh, it
does.
does. So you can, gotcha.
Yeah.
Okay, well
The
maybe
bevel,
that
the,
kind of
be- the bezel
nullifies my,
shouldn't, yeah, it should not interfere, but I understand your point. I think if you really want
yeah,
to mimic the human finger, you should not have any bezel at all. Then you should actually have a curved sensor.
interesting.
There
That'd be
is,
hard probably
it is
computationally.
hard to make, but it is not, again, conceptually, our the technology as I described it, right, of having some kind of a, polymer-like material, some
Yep.
illumination, a camera behind it, as long as you can image that curved area and be able to reconstruct that 3D surface of it, it works.
Hmm.
So I
Huh.
don't think there is, again,
And
a
you can calibrate it pretty robustly regardless of its shape, I would think. So then,
absolutely, it is a complex design. It probably will
mhm.
take a lot of development to make something like this, but fundamentally I don't see any limitations from the technology. It would
Hmm,
absolutely be feasible to do it with curved sensors.
that would be cool. Yeah. I was just thinking maybe there'd be like edge effects. I'm imagining like a soft mattress or something where the edges are easier to fall off than the middle because it kind of gives more on the edges. And I was wondering if that would make it more difficult to sense accurately on the edges if you had no edges. But perhaps it wouldn't matter because you just calibrate um, what it looks like for different
Correct.
deformations.
Correct. I don't think it would be an issue.
Gotcha. Okay, so I would like to segue a little bit to talking about you for this. So you've mentioned that you've been in tech for the last 25 years. And did you say you've been leading in tech for 25 years, or what did you say at the beginning?
Yeah, I've been kind of in leadership positions, for 20 plus years. I spent half of my career in the semiconductor world, so I'm still
Oh.
biased being a chip guy. At ST Microelectronics, I worked in the in a fab that is now closed in Phoenix, Arizona. That's where I started my career after grad school, in operation management. At
Hmm.
that time, I'm an industrial and system engineer by trade. Um,
What was the first thing? What in system?
Industrial and systems engineering.
Ah,
That's what I
gotcha.
studied in undergrad and grad. Um, and So worked in Phoenix. I worked in France, in semiconductors. When I left the semiconductor world, I was leading the 8-bit microcontroller business unit, at ST Micro,
Okay.
and came back to the US to join a company called Digital Optics Corporation, which I moved from electrons to photons at the time. Um,
Yeah.
it was a company that was using wafer level techniques, so still leveraging my semiconductor experience, but to actually build micro optics, diffractive optics, waveguides,
Hmm.
and very tiny refractive lenses,
I- I'm imagining just tiny cameras. Is
very
that
tiny cameras, very
okay?
tiny cameras.
Because I don't know what a lot of the words you've just said mean,
Yeah.
but okay.
so did that for a while. That's actually where I, met the FLIR guys that were developing Lepton at the time. But
Oh,
I
cool.
can't really say much more than that.
Okay.
But I know a lot about Lepton. Um, and we sold actually that activity to FLIR. That's public information. And I decided to move to California at the time because, as a technology geek that I am, I've always felt that where else can you be but in Silicon Valley? So after we sold the site in North Carolina, I moved to Silicon Valley. I worked for Omnivision for a little bit, launched their liquid crystal and silicon business,
Huh.
and joined some friends of mine that were in a company called Photonation, which was a computer vision company, core expertise in face technologies. They've been doing it since the mid '90s, I think, before many.
Hmm.
So face detection, tracking, eventually recognition, and eye tracking, iris recognition, things like that, like that.
Cool.
And got an opportunity to join Magic Leap, the augmented reality startup, where I spent almost 5 years as
Hmm.
their SVP of business development, which helped me really get access to incredibly amazing technologies. Because to build the kind of AR headset that we were building, you're basically at the edge of innovation on every front,
Oh, that's cool.
which was amazing for me. So amazing learning experience.
Hmm.
And decided to take a break. Spent a little bit of time with the family, but as I was doing that, I got introduced to GelSight, and really fell in love with the technology. It kind of had that similar wow effect when I saw it the first time as I had when I experienced Magic Leap in late 2015. Um, and I started digging into it, and I basically noticed that companies in every sector showed interest in GelSight, and I really,
Hmm.
it really intrigued me. Like, it really piqued my curiosity to say, so what should we really be able to do with this company? Um, and after I met the founders team and the staff, I basically decided this was the right choice for me, is to join the company and then help it grow towards this vision of making digitization of tactile sensing um, a reality. And more importantly, I think just bringing tactile intelligence to the world. And, so basically bringing these two pieces of an imaging-based digital tactile sensor plus AI as the way forward, for the company.
Yeah.
And that to me is super exciting. And, I've enjoyed every minute of it.
Hmm. Now, one thing that strikes me hearing about kind of your path is you've kind of like pivoted and kept learning and like I imagine reinventing yourself like each stage. Can you just tell me a bit about that? Like the experience or kind of your heuristics and I don't know. How do you yeah.
It's a great question. I think what gets me excited is learning new things every day, and um, uh, you know, it needs to have that component in my life to motivate me and help me get up in the morning, and that's what I've been doing. Every time, even when I spent 13 years at ST Micro, I basically had maybe 5 to 6 different roles because I kept moving and being
Yeah.
promoted within the company, because as soon as I kind of figured it out, I started getting bored and I needed a new challenge. I needed a new challenge. And, the
Mm.
company had been really great to me by offering many ways for me to get to advance, but
Keep
mainly to
advancing.
learn. And
Yeah.
I always take it as a personal challenge to learn about new technology and to envision the best that can happen with any technology that I'm getting the chance to work with.
Hmm.
And that's just who I am. I'm just driven by this constant need to learn. So
Yeah.
that's what drove me here.
how do you find something that's exciting? Like, how does GelSight get on your radar, or how does augmented reality, or the headsets you were working on, how do these get on your radar for you to consider switching your area to and keep learning in that direction?
I've been blessed over the years to, build a network of people that, um, first of all, know me and they know what I'm capable of doing, but also mainly know that I need that. I need that new challenge.
Okay.
So I've had actually the opportunity to, like the Magic Leap opportunity is just a friend of mine that I work with in the optics company. That's like, Youssef, this is for you. You need to come and please take a look at this. And that's
Yeah.
how really it happened. And I think in GelSight it was a bit of the same. Um,
Hmm.
it's just basically by surrounding yourself with people that appreciate you for who you are and actually just know you. And they know, you know, when something really interesting is out there, you're the guy they think about. It's like, hey, you should take a look at this.
Hmm.
You might be interesting to you. So that's what I that's what I've done.
Gotcha. That's cool. It's interesting how the network can kind of make you aware of different opportunities, and like you hear about everything through your connections in a sense. They kind of filter
Correct.
the topics, and
Correct.
also can recommend like, hey, this is super cool. I
And
think you'll love this.
the other thing I would add is um, my key motivation is that curiosity. So it's
Hmm.
not about the necessarily about the short term financial
Hmm.
stuff. So, when I left Magic Leap, I had the opportunity to join other companies and much bigger companies that would offer me a package of gels that I can never afford. And even if we have a very
Well, if you
nice
guys grow, hopefully, but
yeah,
yeah.
so even if we do really good, it might not even
Uh-huh.
match what I could have done somewhere else. But it was not interesting.
Yeah.
It felt like, to me, I would be one person amongst many,
Yeah.
not necessarily working on the most exciting stuff or being very limited in your scope. Um,
Hmm.
you know, that
So
to
well
me is not
compensated,
value.
but not interesting.
Yeah, and
Not a
that's
good use of your time
I,
to you.
I can't see myself being happy there. I think to be happy, I just need that I need that challenge. I need to be learning some things, and that's why I'm here. It's great.
Hmm. Let's see. So, all right. What advice do you have for someone, let's say, finishing university, um, given like the current climate of everything? Um, what advice do you have for them?
I would say, really um, work at identifying what really gets you up in the morning and gets you excited about contributing to our world in a positive way. Um, at the end of the day, it's what's going to matter in the long run. It's not the material things. It's really about, have you um, have you had fun? Have you learned things? Have you helped others learn? Have you helped others grow? Um, that to me is really, I think, what young people should, not young people, everybody should really think about. But that's the advice I would give. That's the advice I give to my own daughters. But that's what I would say. It's just, you have the foundations, you've learned things. Um, that's just the beginning. And life is going to be about continuous learning, um, and do something where you can leverage what you've learned, but also when you never stop learning, and
Hmm.
where you can actually then share your experience, share what you've learned with others, help others also get ahead. I find that to be very satisfying. For
Hmm.
me, the best thing that I once in a while hear about is my some old colleagues of mine from many jobs ago, tell me, you remember that advice you gave me, on such a day? Well, I just wanted to let you know, I did it 5 years ago, and I feel that I was the best decision ever. That to
Wow.
me is when I hear things like that, which I've been, again, lucky to hear quite a few times in my life,
Hmm.
that what makes me happy. When I hear that, I was like, okay, I've done something good.
Hmm.
Um, so that's my advice.
Let's see. And then one last question. Um, is there any specific things you do or habits or things like this that you think have been very useful to you?
um, I don't know if I have good examples there because I think I would be scolded at, but at home. I think it's also spending time, you know, by yourself. I think just we've just taking time for your own being, just well-being, just reflecting on what matters, to you, enjoying, you know, this earth that we live on. Like, I do a lot of, I enjoy that very much. I'm kind of sometimes too much of a loner, but I, I enjoy that. I mean, I enjoy taking the time to listen to the wind blowing on the leaves out there in Boston is really nice right now. And, things like that. It just helps you to be grounded, I think,
Mhm.
and just enjoying the little things. Um, I like that, very much. It has helped me. The other thing is I don't sleep much. So if you don't sleep much, you have time to do work.
All right. Do you have any links or website, like contact information, anything you'd like to share with our listeners?
Absolutely. I mean, I would encourage everybody to visit, GelSight.com. We also have our contact page there. If you're interested in what we do, or if you just want to give us comments, please, contact us. We would love to hear from the audience. Um, we're here to basically help digital touch happen. So if you're interested in that topic, we'd love to hear from you.
Awesome. Okay, it's been a pleasure.
Thank you. Same here. Absolutely.
Thanks for listening to this conversation with Youssef Benmokhtar. Thank you again to our founding sponsor, Open Robotics, and hope to see you next time.